Dubai. The most extravagant city in the world, with the tallest building, second biggest mall, most luxurious hotel. This absolute grandeur is epitomized by an archipelago of artificial islands that extend off the Dubai coastline called the Palm Islands. Palm Islands consist 3 artificial islands, Palm Jumeirah, Deira Island, and Palm Jebel Ali. Palm Jumeirah was intended to be the first of 3 similarly shaped offshore developments in Dubai. The others, Palm Jebel Ali and Palm Deira, are both much larger than Palm Jumeirah, but remain uncompleted because of economic uncertainty. Palm Jumeirah is the site of private residences and hotels. Palm Jumeirah was built in the early 21st century and was largely financed from Dubai's substantial income from petroleum. The developer of Palm Jumeirah was NAUTICAL, a real estate company now owned by the government of Dubai. The master plan was drawn up by HELMAN CHARVAT PEACOCK, an American architectural firm. The islets were made mostly from sand dredged from the floor of the Persian Gulf, but the side of the crescent, that is exposed to the open sea, was shored up with stones and boulders from the mainland. Work started in 2001, and land and basic infrastructure were in place by 2004. Construction of the buildings began in 2006, and the first residents arrived in 2007. The structural and construction resources involved are massive and listed below. 5.5 million cubic meters of rock brought from over 16 quarries in Dubai. 94 million cubic meters of sand brought from deep-sea beds, 6 nautical miles from the coast of Dubai. 700 tons of limestone. Structure. If observed from above, the archipelago resembles a stylized palm tree, within a circle. Trunk, spine, fronds, and crescent are the names by which the principal sectors of Palm Jumeirah are known. The broad trunk, connected to the mainland by a bridge, serves as the entrance to the development. Another bridge connects the trunk to the spine, a narrow central axis from which 17 fronds protrude. The crescent is a breakwater that nearly surrounds the other sectors. It is divided into 3 sections to facilitate the circulation of seawater. A vehicular tunnel connects the spine to the crescent, and a transit monorail runs about 4.8 kilometers from the mainland to the crescent, through the spine and trunk. The crescent is 650 feet wide, and about 17 kilometers long altogether. At least 1,380 acres of new land were created in all, within an area about 5 kilometers in diameter. Project risks and threats. This enormous project had its own architectural threats and risks such as sinking, waves 2 meters high, annual or biennial storm frequency, weak soil due to constant exposure to rising sea water, water pollution. Risk mitigation. To counteract with the waves and the constant motion of the sea, breakwaters were built all around the island. They were 3 meters high and 160 kilometers in total length. Expanded over a length of about 11.5 kilometers, the base of these breakwaters and the island itself were constantly monitored during construction process with the help of deep-sea divers. The divers checked the alignment and placement of the rocks beneath the surface to ensure its stability. Shape of the island was monitored using GPS. The sand on top of the island was sprayed by a technique called rainbowing. Here the sand from the dredging ships was sprayed onto the land. The whole island was planned such that there was no stagnant water between the island and the breakwaters. In order to achieve this, small structural modifications were made to the breakwaters that surrounded the island, allowing the sea water to move through the breakers without causing any damage to the island. To prevent erosion of the sand from the island, maintenance systems spray material along the coast of the island and also along the Dubai coast. Coastal ecology was recovered with the help of nature itself. These changes began attracting newer species of fishes and also reef formations. Every 6 weeks sea divers go down underwater to check the marine life as part of their monitoring process. Precautions were also taken to prevent the process of liquefaction of the sand on the island, below the upper surface. This process of liquefaction was caused by the movement of the rocks and sand, and also underwater erosion before and after construction. A vibro-compaction technique was used to prevent the process of liquefaction. This was carried out in order to hold the island's base together, and also to make a strong foundation for further construction. Environmental concerns. The construction of the islands has had drastic changes on local marine flora and fauna, coastal erosion, and wave patterns. The origin of most of the environmental damage stems from disturbed sediment from construction of the Palm Islands. The sediment decreased the amount of sunlight filtering down to the sea vegetation and injured the surrounding marine fauna. In 2009, the New York Times reported that the Palm Jumeirah Island was sinking at a rate of 0.2 inches per year. The World Wildlife Fund announced in 2006, the UAE's human pressure on global ecosystems is the highest in the world. The construction has also caused many visible ecological and environmental changes that are a threat to the future. All of this glamour and grandeur comes with environmental repercussions. However, the Palm Islands are a big boost to Dubai's goal of being the most popular tourist destination in the world. Only time will tell how grave the consequences are, but for now it is working out pretty well for Dubai. That was all about Palm Islands for you. Do like, share, comment and subscribe to our channel, Explified.